All right, guys, I'm going to work out a problem. Page 761, number 14. This is how to do a significance test with when you're testing the slope of a regression line. If you read problem 14, this talks about is the relationship between the number of calories consumed and then the amount of time spent at the table. So we're going to go through each part of this problem, A through D. Part A asks, describe what this graph tells you about the relationship between the two variables. Remember that anytime a problem asks that, they are looking for three things: strength, direction, and form. So part A, the answer is the scatter plot shows a moderately strong negative linear relationship between the amount of time spent at the table and how many calories are consumed. Part B wants to know what the linear equation is for the regression line. And remember those numbers, that equation can come from the Minitab output. The y-intercept is 560.65. The slope is negative 3.0771. And so therefore the equation is y hat equals this minus that x. And it says to define the variables. So y hat is the predicted amount of calories consumed. Remember, you do have to use the word predicted. And x is the time spent at the table. And then in minutes, do not forget to include your units. Then part C wants you to define the slope in context of the problem. That is from your throw up list way back from chapter 3. And so in context of this, we would say for each additional minute spent at the table, and pardon me with my mess up there, I scratched that out. So for each additional minute spent at the table, the predicted number, remember you have to use that word predicted, the predicted number of calories consumed decreases on average, you have to put on average, by 3.0771. And it asks about the y-intercept. Does the y-intercept make sense in this problem? Most of the time, remember, the y-intercept does not make sense because usually we do not have data for an x value of 0. And definitely we do not have data here since our chart, as you can see, starts at 20 minutes. So 0 would be extrapolation. Hopefully you guys remember that term from chapter 3. Extrapolation meaning trying to make predictions outside of your realm of data. So what I put here, the y-intercept makes no sense. It states that a child who sits at the table for 0 minutes consumes 560 calories. Well, that's impossible, so it doesn't make sense. Then part D is where we carry out a test, a significance test. Now, even though these tests are very different than what we're used to, they're actually very easy because most of the time, these problems, the conditions will say, or the problems will say, assume the conditions have been met. They'll give you Minitab output that already has the t-score and the p-value in it. Even though your calculator can do these tests, can do a linear regression t-test and a linear regression t-interval, I don't think I've ever used my calculator to do one of those because the problem is almost completely solved for you with Minitab output. But I wanted to go ahead and work through this with you so you can see what it looks like. The name of these is just a t-test for beta. Remember, that's the capital Greek letter beta. It looks like a capital B, but it's technically beta. Then define it where beta is the actual slope. Because remember, all of this is about the slope of the line, where beta is the actual slope of the regression line relating time spent at the table to predicted number of calories consumed. The null hypothesis is almost always going to be that beta equals 0, because that would mean that there is no relationship between the two. A slope of 0 would mean no relationship. Alternative here is that beta is less than 0. The reason why is because the way the problem was worded. It says, do these data provide convincing evidence of a negative linear relationship? Negative meaning a negative slope. So please be careful that you read the problems correctly and use the right alternative hypothesis. The conditions. You guys know from the last video that there are 5 conditions. I went ahead and did the 3 that we're used to doing first. Number 1, is it random? Yes, it was stated in the problem. Is it normal? Well, n was less than 30, so we know we have to plot the data. Now, here's the thing about the normality in these problems with the slope. They did not give you a histogram or a box plot of the residuals, but most of the time they will. As a matter of fact, I can't think of any time where they wouldn't give you that unless they just were going to say, assume conditions have been met. So I wanted to go ahead and tell you that that's what you're looking for. They will usually give you a picture of a histogram or a box plot of the residuals. And that histogram needs to look normal, like a single mound symmetric, or the box plot needs to show symmetry, no severe skewness or outliers. That's what you're looking for. So even though I did not draw that out here, you're never going to have to draw that out because it's probably going to be given to you in the problem if you ever come across one of these on the AP test. All right, I hope that makes sense. Independent, 10% rule, yes, there are more than 200 children. Is it linear? So this is a new one. Yes, they did give us the scatter plot, and the scatter plot shows a linear relationship. You can see that in the book. Equal variance. Again, this is kind of like the normality. They did not give us the residual plot here. They will always give you the residual plot on the AP test, and you can see from that whether or not there's equal scatter around the R equals 0 line. Remember in the last video I showed you guys examples of what equal variance is not. If it makes like a trumpet funnel shape, then that's not equal variance. Equal variance needs to look roughly scattered above and below the line kind of evenly. All right, so all 5 conditions have been met. The t-score is simply b minus beta over the standard error. B came from the Minitab output, negative 3.0771. Beta is obviously 0. The standard error came from the output, 0.8498. So that divided by that is negative 3.62. That's also in the data. If you look in your Minitab output, that is the t-score on the second row. And the p-value I just pulled from that Minitab as well. I didn't do these 2 calculations. I just looked at the Minitab output to get those. The p-value is 0.002. At least that's what it says on the Minitab. Don't forget to put your data over here. Alpha level was 0.01. Sample size was 20. So we've got a really small p-value. So the answer here, since our p-value is less than alpha, we reject the null. There's convincing evidence of a negative linear relationship between time spent at the table and the number of calories consumed. All right, so I hope that answers all of your questions. Good luck taking the quiz, and hopefully you've already taken the test for chi-squared, and I look forward to grading them. Talk to you guys later.